For data communications and network 1 class today, I will talk about the unguided media. This is the transmission through air. Okay, so the medium is air. We will use antenna for transmission and reception. For transmission, we will radiate. Okay, the antenna will radiate the electromagnetic energy into the medium. For reception, it will pick up. Antenna will pick up the energy from the medium. Okay, now we'll take a look at the characteristic at different frequency ranges, because for the unguided media, there is no wire, okay, for the signal to go through. It will go through air. Okay, so the different frequency range has different characteristics, and we have to choose it appropriately for our work. Okay, the first frequency range that we will talk about is 2 gigahertz to 40 gigahertz. Okay, this is the microwave, terrestrial microwave and satellite microwave. Terrestrial microwave is the microwave on Earth, so it's something like this. You transmit on Earth. Okay, this is terrestrial. But for satellite, okay, we will transmit through the satellite. This is my satellite, and this is the Earth station. Okay, so this is the satellite microwave. Okay, they use the same frequency range of 2 gigahertz to 40 gigahertz. These are directional, which means that the antenna, okay, receiving and transmitting antenna must be aligned. It must have line of sight. It must see each other, okay, in order to transmit. Okay, it have to see each other to transmit. Okay, line of sight here. Okay, like this. Okay, now so it use focus beam, okay, to transmit. This is considered point-to-point transmission. Okay, antenna is directional, it have direction to go. Now the next one is the lower frequency, which is the 30 megahertz to 1 gigahertz. This one is used in broadcast radio. For this one is omnidirectional, which means that it go, okay, spread in all directions. So if you have the transmitter, okay, of the radio station, it will go like this, all direction. And if you have receiving area, okay, any like FM radio receiver can receive your signal. Okay, it can go like in all direction. Okay, so this is different from the microwave because it's omnidirectional. Signal spread in all directions and can pick up from all directions. Okay, you don't have to see the transmitting antenna. The next one is called infrared. Okay, this is the frequency of 3 to 10 to the 11 to 2 to the 10 to the 14 hertz. This is very high frequency, but we are familiar with it because infrared, okay, is the remote control. It's used in remote control. Okay, it is good because it does not penetrate wall, so it cannot go through the walls. Okay, so you use the remote control in this room, and the next room also use remote control. They will not interfere with each other. Okay, this is because that doesn't interfere with each other. You don't need the license. No license is required, so you can use it for free. Okay, compared to the broadcast radio, you will have to pay the money to the government to use the radio frequency. For example, you use 100 megahertz, FM radio 105 megahertz, something like that. You have to pay to use the frequency, because when you use, like, for example, 1.5 megahertz, then no one can use it. Okay, because if other people use it, it will interfere with your channel, right? So you have to use it. You are the only one who uses it, so you have to pay the money to the government, because the frequency band is actually belong to everyone in Thailand. Okay, so infrared is good in terms that it does not disturb other people, so you can use it for free. Another frequency that is not required the license is 2.4 gigahertz. This is actually the microwave range. Okay, but this one is also free. Okay, no license. So if you use the cordless phone or some wireless device at home, okay, sometimes they use the 2.4 gigahertz because this is the standard. It is the free frequency. But the other frequency you have to pay like to use it, okay? Now go back to the infrared, okay? Infrared use light offset propagation, okay? So you have to point your remote control to the device in order for them to be able to detect the signal, okay? So this is the difference between the three range of the frequency. Now we talked about terrestrial microwave in this video, but the satellite microwave and the radio we will talk about in the next clip video, okay? The terrestrial microwave use far fewer amplifier or repeater than the coaxial cable for the same distance, and also sometimes it's good to use this, okay? Even compared with the fiber optics, because sometimes you it's not convenient, okay, to lay the line, okay, across the terrain. For example, even if it's short distance like this, you have buildings, right, and you have like the road in between, okay, and it's difficult to have the fiber optic across the street or across the road. If you put the microwave link on top, okay, then you have no problem, something like that. Okay, this one again requires light offset transmission. We talked about this before. And the taller the antenna, the longer the side distance, okay? If you have no obstacles, okay, which means no buildings, no house, no nothing in between, okay? The maximum distance that you can achieve, okay, between antennas, follow this formula, okay? Be careful that distance is in kilometers, D in kilometers, but H is in meters, okay? This is different units, okay? K is the adjustment factor of approximately 4/3 because the earth is curved, okay? So if you send for a long distance, okay, it will hit the curve of the earth, okay? The earth is not flat, okay? So this is adjustment factor. Now, if you want the H to be high, okay, you have so usually you may have seen, okay, they put it on top of like hills or mountains, okay, so that the H value will be high, right? So line of sight again, okay. Now if you want long distance telecommunications, like telecommunications, then you can put a series, okay, of microwave towers over here. So it's like a relay tower. So you send first one, okay, send to the second one send to the third one like this, okay. So you can send for a long distance. This is for application is long distance telecommunications and the short point-to-point links between buildings like this, okay. So you can go over countries with the microwave link and you don't have to lay the fiber optics line. Now let's look at the loss in the microwave transmission. The main source of the loss is called attenuation, okay. We have talked about attenuation before in the last chapter. And this loss for microwave is called part loss or free space loss, okay. It's because it's the loss when you go over the air, through the air, okay, because the energy is spread out, okay, as electromagnetic wave propagate from the source, okay. So you can see that the beam and it's spread out, okay. So that is attenuation. And note, okay, that attenuation increases rainfall, okay, especially when the frequency is more than 10 gigahertz. So for satellite dish, okay, when you receive the TV, and it's raining hard, then sometimes you lost your signal, okay. The signal is not very good quality at that time, okay. Now for the microwave loss, okay, it's vary as the square of distance, okay. So it go down quickly. The power go down quickly because square of the distance. In dB is this formula here. Everyone should know this formula, okay. L equal to 10 log base 10 of 4 pi d over lambda square, okay. D and lambda is in the same unit here because there is no unit for the dB, right? So if meter is have to be meter, if kilometer is have to be kilometer. Both of them have to be the same unit. And recall that the wavelength is this formula. You should know this already. Lambda equal to c over f. C is the speed of light. 3 times 10 to the 8 meter per second, okay. Now, from that formula here, okay, you can write it, okay, in another form in terms of power. So sometimes you know the power, right? You know the transmitting power, PT, and the receiving power, PR, okay? But you don't know the distance and the lambda. So you can use this formula also. And the second one is this, okay? Actually, the power formula is the general formula, okay, for any system, okay. So, but the second one is for the microwave transmission, okay. And from the microwave transmission, you can take the number 2 down and it's become 20 log. Okay. If you change the lambda, okay, into C over F, okay. So sometimes you know the frequency, okay, you don't know the lambda, you can change the formula to this. And if you take it out in terms of log, okay, summation of log, okay, so you can have a constant here, okay, and this is just a summation. Now take a look at this. This is the loss in dB, right? Okay, and this is a distance, okay. This is different frequency. The higher the frequency, the line go up, okay. Let's look at distance of 8 kilometers. 8 kilometers, frequency of 30 megahertz. Okay, you can read it like this. So you have a loss of 80 dB. Okay, so you can read it like this. Now why is become a kind of a straight line? Okay, because this is constant, right? This is constant. And if the distance is the same distance, okay, the line here, same distance, then this is become also constant, okay? So it's very based on the frequency only. That's why it's a straight line and change only with the frequency. Okay, so this is related to this picture here. Now examples, okay, of receiving powers at different distance. Suppose we have different distance of D1 and D2, and this is the transmitting point. This is the source, okay. You have distance here and distance here. So any point at distance D1 has a power of P1. Any point at distance of the same distance of D2 has a power of D2. What is the loss? Loss at D1 is, okay, so from the formula, the rate formula here, we got this, okay, and this. So just put the P1 and P2, D1 and D2 here. Then I divide the equation 1 by equation 2, right? When I divide equation 1 by equation 2, so P2 will flip to be up in the numerator, right? So we get this formula here. This is an important formula and it's very useful. Okay, so this is transmitting point source, okay, anything receiving at D1 and anything receiving at D2. Okay, they have different power. Now, what if D1 and D2? D1 is half of D2 or D2 is double the distance of D1. Okay, then P2 over P1 will be 1 over 4, right? What is 1 over 4? In terms of loss, in terms of dB, 10 log 4 is 6 dB. So you can see that this is to the square, right? That's why it's become 1 over 4 becomes 6 dB. Therefore, every double of distance will cause 6 dB loss, okay, for microwave transmission. Suppose loss at D1 equal to L1, okay? Loss at D2, okay, suppose D1 is 100 meters, D2 is 200 meters, so its double distance will be D1 plus 6 dB. Loss at D2 will be L1 plus 6 dB, okay, like this. So if you have another double distance here, okay, D3, okay, and P3, okay, so you, if double the distance 3 is double of distance 2, okay, you plus another 6 dB. Every time you double distance, you have a loss of approximately 6 dB increasing, okay. Now, to compare with the guided media, I want to take a note, okay, on the guided media attenuation. This is very simple. The formula is just this, okay. It's like just to parameters multiplying the attenuation is equal to a specific attenuation, okay, which depends on the type of the transmission line, and it's have the unit of dB over kilometers, okay. For example, 0.2 dB over 0.2 dB per kilometers, okay, something like this. So if you transmit 10 kilometers, it's going to be 2 dB. If you transmit 5 kilometers, it's going to be 1 dB, okay. So it's very easy formula, okay, but be careful that this is linear in dB. So the actual value, absolute value, okay, is not linear, right? Because the dB is like log scale, okay, but it's linear in dB. Now, when you want to select, okay, to decide whether you should use the optical fiber or microwave, okay, in terms of loss, okay, you have to compare with this formula. So this is the wire, okay, media, and this is the wireless, okay. This is the wireless, the microwave formula, right? So you calculate, okay, to see whether the guided or the microwave, which one has less attenuation. When you want to decide, which, in terms of, loss, which media should you use. So it depends on the frequency, depends on the distance, depends on the specific attenuation, okay. So that's it for today. And we will have the next clip on the satellite, microwave, and the broadcast radio. Thank you.